In this lecture, we will cover the convolutional layer in a convolutional neural network. This layer is based on the convolution operation. In this operation, we use a kernel or a filter to extract some meaningful information from an image. Let this be a 3 by 3 kernel that has 3 rows and 3 columns, and let this be a 6 by 6 image with 6 rows and 6 columns. Our goal is to find some meaningful information and store it into a 4 by 4 output channel. So the way to go is to take the 3 by 3 kernel and match it with the first 3 by 3 rows and columns of the input image. How we do that is we multiply 3 by 1, then we multiply 1 by 1, then we multiply 2 by 3, then we multiply 2 by 0, then we multiply 2 by 1, then we multiply 2 by 0, then we multiply 0 by 1, then we multiply 1 by 0, and finally we multiply this 2 by 0, and then we add up all these values. The answer is 12. Essentially, we used these 3 by 3 rows and columns of our input image and convolved this kernel over these 3 by 3 pixels. So we can put that 12 here. Next, what we do that is we move this kernel 1 point to the right, like this, and we do the same operation again. We multiply 1 by 1, 3 by 1, 2 by 2, 1 by 2, 0 by 2, 0 by 2, 0 by 0, 0 by 1, and 4 by 2, and the answer must be 18. So we can put that 18 here. The next step is to move it 1 point to the right and do the same operation. Multiply 1 by 3, 1 by 2, and so on to multiply 2 by 4, and then add up the values. The result must be 19. So if I keep filling this output channel by sliding it to the right, I will get the next value as 21. The next step is to start from the second row, like this, and multiply 0 by 1, 1 by 1, 0 by 2, 1 by 2, 0 by 2, 0 by 2, 6 by 0, 4 by 1, 5 by 2, and add up the values. Now we will get a 17. If we keep filling this table in the same way for all other slidings, next is this one, the next one would be this one, and finally we move to the last one, and here we will get the value 43. So if you perform the following calculation, that is the ij pixel of the output channel equals the summation from m to n, the kernel mn multiplied by the input image I. Consider this equation again. S means the output channel, K means the kernel, and I means the input image. So using this equation, we have filled in 6 values. Now suppose we are at this point. If we convolve it, that is here 1 multiplied by 1, 1 multiplied by 0, 2 multiplied by 0, 2 by 0, 2 by 0, 2 by 4, 0 by 4, 1 by 5, 2 by 1, and we will get the value 16 after summation. Essentially, we are using this equation and applying it to the input image using the kernel and finding the output. The next point is padding. Let this be the input image denoted by I with the width of 6 and a height of 6. Let this be the kernel with a width of 3, height of 3. Let this be the output channel denoted by S with a width of 4 and a height of 4. The convolutional operation is reducing the dimensions of the image from 6 by 6 to 4 by 4. Sometimes we want the dimensions of the output to be the same as the input. For that purpose, we can add extra zeros to the top, to the bottom, to the right, and to the left, and 4 extra zeros here. This is now called a zero padded image. When the kernel is applied on this image, we start from here. 0 multiplied by 1, 0 multiplied by 1, 0 multiplied by 2, 0 multiplied by 2, 3 multiplied by 2, 1 multiplied by 2, 0 multiplied by 0, 0 multiplied by 1, and 1 multiplied by 2. When all these are added up, we will get a 10. That 10 will be here. When we move it one point to the right, like this, and perform the same operation, 1 multiplied by 0, 1 multiplied by 0, 2 multiplied by 0, 2 multiplied by 3, 2 multiplied by 1, 2 multiplied by 3, 0 multiplied by 0, 1 multiplied by 1, 2 multiplied by 0, and when added up, we will get a 15. We move it to the right and get something here, then to the right, something here, to the right, something here, to the right, something here. Then we move it one point to the bottom. Perform the same operation. We will get an 8. And rest is the same for all these places. Now the dimensions of the output are 6 by 6 instead of 4 by 4. Exactly what we wanted. Now if we know the dimensions of the input image and the dimension of the kernel, we can find the height and width of the output. We can use this equation. Width of S equals the width of the image minus the width of the kernel plus 2 into padding. Here we added one border of zeros, so P will equal 1. Similarly, the height of the output is the height of the input minus height of the kernel plus 2 into padding. Plugging in the values will simply yield 6 here and 6 here. Let me show you. This is 6, this is 4, and this is 2 by 1. So that gives us 6. Same goes here. The next point is the stride. Notice that when we place the kernel here at first and calculate the first entry, then we move it 1 point to the right. That means we are using a stride f of 1. What if we moved it 2 points to the right? That is, after calculating this entry, we move it to this. Then we will say the stride is 2. What if we moved it 3 points to the right to here? From here, we will have a stride of 3. Similarly, when moving to bottom, when we are at here, with the stride of 3, we will move here. So, let's calculate the entries. When we are here, we apply this kernel 1 into 3 and 2 by 1, 0 by 1 and all zeros. We will get a 12. Now when we move the kernel to here with a stride of 3 and multiplying the corresponding entries, multiply 2 by 1, 1 by 1, 2 by 2, 0 by 2, 0 by 2, 3 by 2, 0 by 4, 4 by 1, 2 by 2. Adding up all these will give us a 21. We place that here. We now move it here and correspond it to the kernel. Multiply 6 by 1, 4 by 1, 5 by 2, 5 by 2, 5 by 2, 0 by 2, 1 by 0, 2 by 1, 4 by 2, and add the entries and we will get a 50. So when the kernel is here, doing the same operation will give us a 43. Now you can see that the size shrinked from 6 by 6 to 2 by 2. If we know the dimensions of the kernel, which is 3 by 3, and the dimension of the input image and the stride and the padding, we can formulate the dimensions of the output like this. The height of output is height of the image 2 into padding minus height of the kernel divided by the stride and an addition of 1 here. Similarly, the width will be width of the image 2 into padding width of the kernel divided by the stride. In our case, padding is 0. That will, and kernel's height is 3, stride is 2. So you get a 2.5. Round that downwards and you get a 2. We always do this. This is called the floor operation. And similarly with the width, we get a 2.5. When floored, it goes to a 2. This is how we calculated the dimensions of the output kernel. Now we have an input layer and a convolutional layer. The input layer has 3 channels, the red, green and the blue channel. And the convolutional layer has n kernels. N can be any number, but it is usually taken as a power of 2, such as 16, 32, 64, 128 and so on. The width and the height is the same at each kernel. That is, K1W and k2w. Width of k1, width of k2, both are the same. Similarly, the height of k1 and height of k2 are both same, and so on up to the nth kernel. Each kernel is producing the same padding, that is either 1, 2 or none, and each kernel is doing the same stride for all the kernels in the layer. Now for that reason, that if the first kernel is producing an output of dimension wh, the second kernel will produce an output of the same dimensions, and that will be true for all of the n kernels. As a result, the total output of the convolutional layer will have the shape NWH.